Alright, in this video I'll be answering a grade 12 mathematics question paper based on Euclidean geometry. So without a waste of time, let's see what we have in question 4. In the diagram we have the center P given the coordinates -3 and 4, and we have the endpoint which is the diameter VW, and then the coordinates of V is K and 1, and we are told that B and C are the intercepts, and we are also given that BCV W is a second quadrilateral, and we also have the angle which is OTC given alpha. So let's go to question 1. The radius of the cycle is root 10. The radius of the cycle is root 10. So calculate the value of K if point V is to the right of P. So we know the distance between P and V, which is root 10, and we have the coordinates of P and V, except the fact that K is unknown, so we are required to find what is K. So to find the value of K, we can use the distance formula between point P and V, which is equal to PV squared. We're going to replace x1 minus x2 there, this is x, and we square it, plus y1 minus y2, and we also square that. So we're going to substitute these points, these 2 points P and V here, not forgetting that one of our x is going to be K, and we know that PV squared is root 10. So when we substitute that, you can pause the video and do it by yourself and confirm that the value of K will be equals to -4 and -2. So remember the statement, it says that this point V is to the right of point P, and we have 2 values here. So if we check in point P, we know that our x value is -3, and to the right we're going to have -2 and -1 and 0. So if we check from the values that we have found here, we see that -2 is to the right, but -4 will be right here, which is to the left. So we are looking for this one. So our K will be -2, So that is the second question. The equation of a cycle is given as this one, and calculate the length of BC. If we look at BC, we know that BC is the y-intercept. So since B and C are the y-intercepts, and we are given the equation, so we know that here is going to be 0 and something, and then our C as well is going to be 0 and something, and we're looking for the value of y, and we know that the equation said we must calculate the BC, and BC is the distance between B and C. And if we can know the values of y there in BC, we can simply say value of y at B minus the value of y at C is just the distance between B and C. So how do you find these values? Remember, these are the y-intercept, that's where the x is 0, so we can substitute 0 at the x values, and we're only left with only this equation, and that equation in a factorized form is just y minus 5 and y minus 3, which is equals to 0. Y minus 3, yeah, this is 3. This is 3, and that means our y is going to be 5 and 3. So this will be 5 and 3, and 5 minus 3, that's the distance between B and C. So the answer to that is 2, which is 5 minus 3. That's 2 units. We go to 4.3, which is the last question. 4.3. If k is negative 2, of which that's what we found when we calculate, what is alpha? So we know that our alpha can be found using this formula. Tan alpha is equal to the gradient or that angle. So we know that V and W are the points, and we know the point C here, which is 0 and 3, sorry, 0 and 3 we calculated previously, and here is negative 2. So we can find the gradient between V and C. After finding the gradient between V and C by using the change in Y over the change in X, we are going to find that the gradient is 1. You can confirm it substituting this point in this formula, which is well known. So we can take the arctan of 1, which is the gradient, and then we find that our alpha is just 45 degrees. Can confirm that with me by substituting your gradient between V and C, because you have the points. C is 0 and 3, and then V is negative 2 and 1. So you can find the gradient M and take the arctan. You find that your alpha is just 45. So the next question says VWB. What is VWB? VWB, we are looking for this angle. What is that angle? So we can use our theorems, since this is a cyclic quadrilateral given there, that this is a cyclic quadrilateral. So we can say that, okay, since this is 45 and then y-axis is perpendicular to the x-axis, so this is 90 degrees. So we know that this is also 45 degrees, right? Angles of triangles add up to 180, because 45 plus 45 plus 90, that's 180. So we can also use that theorem. The exterior angle of a cyclic quad is equal to the opposite interior. So that means VWB is also 45. Is also 45 degrees. Or if you don't want to find it that way, you can say that since I have 45 here, you can firstly find the, let me change the color. You can find, since you know this one is 45 degrees, and you know that angle on the straight line, you can find this angle on the straight line add up to 180. So this is 180 minus 45, which is what? 135 degrees. And then you can use that theorem that says opposite angles of a cyclic quad add up to 180, and so you say that 180 W plus C is equal to 180. W plus C equals 180 degrees. So therefore what you see is for the 135, so we're going to say W is 180 minus 135, which is still 45 degrees. We're done. So I'll see you in the next video. Thank you for watching.